All right, so in our review here, we graphed y equals cosine x on this interval, from negative 3 pi all the way to positive pi over 2. Okay? We just plotted the specific points at 1s, 0s, and negative 1s. Okay? I want to talk a little bit about the characteristics of this graph now. Okay? The first characteristic I want to talk about is amplitude. Okay? Any idea what amplitude is?
It's like the heights of the waves.
The heights of the waves. Yep, the heights of the waves. This is kind of a wave here. Okay, it continues on forever, and amplitude is exactly that. Okay, amplitude is the height of the graph, of the wave on the graph. So amplitude is like the height of the wave. Height of the wave. So here's my question to you then. Okay? What is the height of this wave? You always get a couple, I usually get two answers here.
2 or 1. 2.
And the answers are either 2 or 1. Okay? Here would be my question to you. Let's pretend this is water. Alright? And there are waves flowing along here. What if the waves stopped? Where would the water be?
At x-axis.
At 0, right along the x-axis. That would be level water. The x-axis would be. So if the x-axis is where the water would level out when there are not waves, we call that 0. Okay? How high then are the waves compared to the water when there aren't waves? Just 1 unit. Okay? So our amplitude for this function is just 1, because this is where the water would level out. The waves end up only going 1 unit above that. So our amplitude of this function would be 1. Okay? Next one. Period. Period is how long it takes to complete one wavelength, or to complete one cycle. All right? So I'll just write that first. How long it takes to complete one wavelength. It's spelled cycle. Okay? How long it takes to complete one wavelength. How are we going to measure that? How are we going to tell? What does it take to complete one cycle or one wavelength? Drew, what do you think?
Maybe just the top of one wavelength to the top of the next.
You want to use tops? That's great. Top of one to the top of the next one. Perfect. Could you use bottoms?
Yeah.
Yeah? If you use zeros, though, what do you got to be careful of?
Like which side?
Mm-hmm. Yeah. You could go top to top. You could go bottom to bottom, but don't just go 0 to 0, because from 0 to 0 is that one wavelength. No, it's just half of a wavelength. To complete one full cycle, if you're using this 0 right here, you got to remember this is the wave on its way up. So when you get to here, that's not one full wavelength, it would be here. So from here to here, that is one wavelength. Okay? Or this is one wavelength. From the top to the top, or from the bottom to the bottom. That is one wavelength. Okay? How long is the wavelength, or how long is the period on that graph?
2 pi?
2 pi. Yep, 2 pi. Because to go from negative 2 pi to 0, you went 2 pi units for it to complete one full cycle. Okay? So the period equals 2 pi. Alright? So the period on this graph is equal to 2 pi. Did it really matter what interval I graphed this graph on? Would the wavelength and the period still be 2 pi? Nothing changes, right? Okay. How about for sine? How about for the graph of y equals sine x? Is the wavelength, or is the period also 2 pi? Is the amplitude also 1?
Yes.
So they don't change, do they? So for sine and for cosine, for just your regular generic sine and cosine functions, the amplitude is 1 and the period is 2 pi. So any questions on that? Are we good? Give me something, guys. Yeah?
Yeah.
Okay. All right. I want to teach you a little bit about graphing calculators in these. This will be beneficial to you. You don't need them. You definitely don't need them. But I think it might help you. All right. If you want to use your graphing calculator to help you, first of all, on the x-axis, we are counting by radians, correct? Pi over 2, pi, da 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 da, okay? You need to switch your calculator to radian mode for that. So make sure on your mode, you go down here and you're in radian mode. Then our window. Let's say we just want to graph y equals sine x from negative 2 pi to positive 2 pi on the x-axis. Okay? So then what I would enter then for your x min and your x max would be negative 2 pi and positive 2 pi. It's going to change those to decimals, but you'll know that you'll be able to tell pretty easily that it's negative 2 pi because it changes it to 6.28. You can still have it count by 1, or if you wanted to, what did I have you guys count by every tick mark? Pi over 2. If you want each tick mark on the x scale to be by pi over 2, so it matches what you'll end up drawing when I give you some specific graph paper for these. Okay? You could make it match that. You don't have to. You can leave it at 1. I don't know how important that is to you. Okay? But you definitely can change your scale or what it's counting by to being pi over 2. Now, we know the amplitude is 1. I really don't want it to be spread out from negative 10 all the way up to positive 10 on my window. I think that's too high. The graph's going to look real small then, right?
Yeah.
So I'm going to change this, but I don't also want it to go all the way to the top of the screen. I kind of want it to be about in the middle. So I'm going to change this to either a negative 2 to positive 2 or negative 3 to positive 3. I don't care what you do. I think I'm going to do 3s just because I like the number 3. No particular reason.
Lucky number 3.
What?
Lucky number 3.
Yep. So I made sure I was in radian mode, and then I messed with my window to have it be what I want. What questions are going through your head, if any, right now? Going once, going twice? Okay? Alright. Now let's go to y equals. Clear off any graphs you may have there. If you have any highlighted plots from statistics, please go up there and unhighlight them. Okay? So go use your cursor to go up there, press enter. It'll unhighlight plot 1 or plot 2 if you need to unhighlight them. Yeah, get them unhighlighted. You don't want those on right now. Okay? And let's just do sine x. Y equals sine x for our graph. And then if you hit graph, you'll see your nice sine function.
How'd you put X in there?
What's that? The x is right here. There's an x, there's a t, there's a theta, there's an n. but it'll be x because of the mode we're in right now. Okay? So you can at least see what the graph is supposed to look like. Okay? Take the first problem of the day that I gave you. You had to graph cosine from negative 3 pi to pi over 2. What would you change so you're looking at what the graph should look like when you graph it?
The window.
You have to change your window,
And then the cosine.
and obviously graph the cosine function if you want to see a cosine graph, right? So you change y equals to cosine x, and then you have your window, instead of being from negative 2 pi to positive 2 pi, you change it to be from negative 3 pi to pi over 2. Okay? So you can use your calculator to help you get an idea of what the graph should look like. So when you enter your, or give yours to me on a test or something, you can kind of say, well, it looks like what my calculator says, so I must be doing all right. Okay? Also, if you really get good at these, you can even kind of use a table of values to confirm a couple things. Go to your table setup. It's above window. Let's go ahead and start our table at 0. And again, what did we count by in the x direction?
Pi over 2.
Pi over 2. So let's tell it to count by pi over 2. Let's enter pi over 2.
Keep it on auto.
Keep it on auto. So table start is 0. This is pi over 2, 1.57, half of 3.14, pi over 2. Okay? And now if you go to your table of values, which is above graph, if you go to table,
I have to change that to pi over 2. Table.
you'll see all the values that would be plotted. Unfortunately, they don't give you pi and pi over 2 and 3 pi over 2. You need to know those, but they're there just as decimals. Okay? At 0, the graph is at 0, 0 comma 0. At pi over 2, we're up to 1. So at pi over 2, we're up to 1. Here is what? Pi. So at pi, we're back to 0. 3 pi over 2, we're down to negative 1. And what's this one? 2 pi, we're back to 0. Okay, so you can kind of even have the table help you if you were struggling a little bit. Okay, but again, you would need to be able to know what to tell the table to count by. All right? I'm just trying to have you use the technology a little bit to help you make sure the graphs are correct. Questions so far? Okay? Might be a little bit overwhelming right now, but if you do a couple of them this way, you'll start to get pretty good at it. Okay? Some people really used their calculators a lot last year in helping them graph. Okay? All right. Any questions? Okay. Watch right now then.
What do you do?
I'm going to put a 2 in front of there. What's that going to do?
Let's make the height double the amplitude.
Double the amplitude, Caleb says. Anybody agree, disagree? Want to argue with him? You guys are real quiet this morning. You're kind of killing me. Was he right? He was. Good job, Caleb. Okay. What if I make it a negative 2? So here's the 2. It goes up to 2 and down to negative 2. What do you think that's going to change?
It'll flip it.
Flip it. Reflect it over the x-axis.
Let's make it skinnier.
He's right again. Good job.
I'll be half.
It's nice of you telling me answers, Drew. Right? Sorry, Gil. It did. It reflected it over the x-axis. Okay? Is the amplitude still 2, though? Amplitude's still 2, though. The height of the waves is still 2. Okay? So, any number you put out in front of your sine or cosine, if you made that a 3, amplitude is 3. Made it 4, the amplitude is 4. You just make the waves go higher.
What about half?
Okay? Half shrinks it to a half.
So will it always be 2?
Okay? The period?
Yeah.
Nope. I'm about ready to change that. But, okay. If all I do is put a number out in front, yes, the period remains 2 pi. I have not changed how long it takes to complete one wavelength. Okay? Alright, so let me get back here, get our original one up. I'm going to have my window just go from 0 to 2 pi, so you're just looking at that right now. So there's our one period, right? From 0 to 2 pi, it completes one cycle, one wavelength. Everybody good with that? Okay? And we know if I throw a number in front of sine, it just makes it go up higher like that. Okay? To make the period be less, an idea.
Divide the whole thing by a number.
Divide the whole thing by a number. If you divide the whole thing, it really, like if I divide this by 5, it'd be like saying 1/5. So all that's going to do is lower my amplitude. Jake?
Put a number in front of X.
Put a number in front of an X. Yep. So, if I go sine, I want you to see both of them. If I go sine 2x, what happens?
That looks really weird.
Shorten the wavelength. So if you can follow this here, I'll maybe outline it in blue. Here's our new one. So that's this one right here. What do you notice? Wavelength shorter. How much shorter? Exactly half of it, because it completes what? 2 wavelengths in the time that the original one took to complete 1 wavelength. So, if we know that the graph, remember this was 0 to 2 pi, right? That's my window, 0 to 2 pi. So in 0 to 2 pi, it actually completes 2 wavelengths. How long is 1 wavelength? Pi. Half of 2 pi, which would be 1 pi. So it completes 1 full cycle in pi units. Okay? So now our period would just be pi. It was cut in half. Alright? I'm going to change it to 3. Thoughts? Now it completes 3 of them. It'd be 1/3 of 2 pi. And what's 1/3 of 2 pi? 1/3 of means to multiply 2 pi. 2 pi over 3. 120 degrees, if you think in degrees. 120 is 1/3 of 360. But 2 pi over 3 is how long that period of this one would be. Okay? So when I had a 2x there, the period was just 1 pi. When I put a 3 there, the period is now 2 pi over 3. What if I would put a 4 there? 3 pi over 4? 2 pi over 4. Because how long did it take the original? 2 pi. If I'm dividing it by fourths, 2 pi divided by 4 is what would be the new period, which reduces to pi over 2. Okay. What if I put a 5 there? 2 pi over 5. Yep. So whatever number goes there in front of the x, take 2 pi and divide it by that number, and that is what the new period will be. Okay? If I put a 10 there, okay, 2 pi over 10, or pi over 5. What if I put a 1/2 there?
It would double the, it'd be 4 pi.
Be 4 pi, yes.
Bam.
0.5x. So there's my original coming, and now here's the new one. The new one got stretched horizontally. Okay? Now it only does the top half in 2 pi. It'll complete the bottom half in another 2 pi, so it would take 4 pi to complete one wavelength for that one. Alright?
So it takes 2 circles. Good job.
Essentially, yes. Yes. Okay? So, a quick little summary. I'm getting ahead of where the other class is going to be, but that's alright. I can give you more work time. I give you a quick little summary here then. For sine and cosine. For the regular sine and cosine graphs, the amplitude is always just what?
1.
1. But if I throw a number in front, 2 or 5 or 7 or -8 or -12 or whatever,
The amplitude.
what is now our amplitude?
That number.
That number. So if I call that number A, what is our amplitude?
A.
A, or I'll even put an absolute value of A. Because if this A was a -7, what would we say our amplitude is? 7. We're not going to say our amplitude is ever a negative amount. There's no such thing as a negative height for a wave, okay? The height of a wave is always going to be positive, all right? So my amplitude will always equal the absolute value of whatever A is, okay? Please don't put a negative amplitude. I hate to give you a B because of that, all right? Amplitude's always positive, all right? Amplitude's always positive. It's a height, okay? So the amplitude is always determined by this number right in front of sine and cosine, okay?
Is there ever a way to move it down from 0, like so?
Yep, we put something back here.
Oh.
I'm not getting to that today, but yeah.
And then would that have like a negative amplitude?
Nope.
Then? Oh.
Nope, because we still think of, okay, if the water was level, how far, what is the height of the wave? Even if level is not the x-axis anymore, if we slide everything down, we'd still think, what is the height of the wave if the water were level? Oh, okay. And my period will always equal how much? Well, what was the regular period on just y equals cosine x, or y equals sine
2
x? 2 pi. But if I throw a number in front of there, what do you got to do with that 2 pi?
2 pi.
Divide it by that number, or b in this case, right? So the period will always be 2 pi divided by b. Rules to definitely know. Okay? Rules to definitely know.
Sleep in there.